Welcome to this channel. In this video, I'll give you a brief introduction about electromagnetic wave theory, antennas and transmission line. If you are a student of electronics and communication engineering or electrical engineering, you'll be having this course in your second and third year over 2 semesters. So I'll give you some idea about this course. This is very much useful for your VTech life. So now I'll start with the syllabus. I'll give you the total syllabus for this course, and I'll be also giving you the brief discussion, or I'll discuss briefly about some important topics which will be most useful. And also toward the end of this lecture, I will discuss the names of the books which I prefer, and I suggest the students to read it. Okay, so let us start. Now the first topic in this EM theory, that is electrostatic, and this electrostatic deals with the static charges. Meaning is that if the charge is under rest, they are not in motion, then whatever field it will generate or whatever potential will be getting in the space, everything will be discussed in this electrostatic. So if you have one positive charge here, we can have one negative charge, then we can find one field, electric field in the space. So here the most important concept is that the field. So field is too much important for you, okay, and you need to understand what the meaning of field. So here we will be considering two type of field. One is called scalar field, another one is called vector field. So here electric field is a vector field because it is having one direction at every point, but scalar field will not have any directions, but its magnitude will be there, okay, like temperature field or potential field, those things. So we'll be discussing this thing in detail in future videos, what is the scalar field, what is the vector field, and how to use those things. So here mostly this electric field, magnetic field, those will be coming in vector fields, okay. So to understand this electrostatic, so first thing is Coulomb's law that you need to understand, and that is very easy, that if you have two charge Q1 and Q2, then one charge, suppose Q2, will experience one force due to Q1, and that value is K times some constant I can use Q1 Q2 upon R squared, where R is the distance between these two charge. Okay, so if these two charges are having the same sign, so each charge will be repelled by others. Okay, and if they are having opposite sign, they will be attracted to each others. So this sign we have shown, we are assuming that Q1, Q2, they are having the same sign. Both are positive or both are negative. They are repelled. This is direction. So this is a vector. Okay, this is a force, obviously this is a vector. So we need to understand vector well. Okay, so in this electrostatic, Coulomb's law is the first one. Then we need to consider the Gauss law. That is another important thing. So total surface integral of the displacement density vector equals to, so we can write that this one as, so if this D is displacement density vector, that we will discuss later, but this is D equal to, so this electric field is E, okay, D, it's independent of the media, it's epsilon into E, that I will introduce first, and this displacement vector dot ds vector or dA, here I have written dA vector, this total surface integral will be equals to total charge enclosed within this region. So if this region is having one charge plus Q, so total displacement density vector over this surface will be the charge within this one. So that will be discussed in detailed way. There are lots of application of Gauss law. So not only for discrete charge, it could be for distributed charges. That will be discussing in my future videos. But one thing is that to understand electrostatic or magnetostatic everything, we need to understand vectors. So vectors is the most important concept. So here we will discuss the vector in detailed way. So vector, it could be in 3-dimensional space or 2-dimensional space. So if I consider it's a 2-dimensional space, this is x and this is y, then any vector A could be written as some component along x, it's x direction, and along this y, I'll call a y direction. Okay, and two vectors we can add it. So if I have another vector v vectors, so it's a bx x vector and by y vector. It could be 2-dimensional. It can have one more dimension, the z direction, a z vector, or it is a bz z vector. Okay, then we can add simply these two vectors to get a new vector. So component wise, simply we can add it. Its value will be ax plus bx x vector, ay plus by times y vector, and az plus bz times z vector. Similarly, you can subtract these two vectors. Just I will put subtraction here. So it's very easy to understand addition and subtraction of the vectors, and we can find the magnitude as well. So what is the magnitude of this vector? So that will be square root of those magnitudes, ax square, ay square, and az square. Okay, so those things you need to understand. So I'll be discussing in detailed way. And next one, the important thing is vector dot product. So I have two vectors. Okay, in these two vectors, a vector and b vector, so I can take a dot product of these two. Okay, and it is given by a magnitude of a magnitude of b times cos theta, where this is a vector and this is v vector. Okay, and the angle between these two vectors is theta. Then magnitude of a magnitude of b into cos theta will give you the dot product of this one. And whereas the cross product a cross b will be simply mod of a mod of b and sin theta. And this is a magnitude, but it will have one direction as well, that is perpendicular to this both the vectors containing the plane containing this a and b. If this is a and this is b, and if this is the plane, and we can have one direction which is perpendicular to both of them. So this is your n vectors. Okay, so it could be in opposite direction, it could be this side. So we need to consider a cross b with the right hand rule. That will be discussed in this side. So it could be this side as well, but it is a perpendicular to this plane. Okay, and how to compute this a dot b and a cross b, that is also very easy. So a dot b is simply component wise you will multiply ax into bx, then ay into by, and az vz, and then add it. You will be getting this magnitude. And similarly here, this magnitude, the magnitude of a cross b, that also you will get, or you can consider this total, even this total things a cross b, we can write in this form x, y, and z, and this is your ax, ay, az, bx, by, and bz, and this determinant will give you a cross b. So these things are important, you need to understand. We will be discussing in detail in my videos, but this video I am just discussing this thing very briefly. What are these? Okay, Next, you need to understand gradient, divergence, and curl. Okay, so I have already said that we can have two kind of field. One is scalar field, other one is vector field. So if you use a scalar field V, that is a function of space x, y, and z. This is the scalar field. So gradient, the grad of V, that will give you the direction and magnitude at which it's the direction at which the function is increasing rapidly with maximum rate. That is the meaning of gradient. And that gradient we can compute in Cartesian coordinate system as del v del x, x vector, del v del y, y vector, and del v del z, z vector. Okay, so if you have this kind of, this is your x, y, and z, and I have one space, the scalar field, this field, this is the field, and field is increasing. Suppose its value is v1 at certain in these boundaries, and at this boundary its value is increased to v2. So which direction it is moving faster? So you can see that this vector is, this field is increasing in this direction here, and this direction it is this direction here it is this direction. So these are the direction for this gradient. Okay, those will be discussed in detailed way. When a function is increasing or expanding, in which direction it is increasing with maximum rate, that is called gradient. And divergence we'll discuss. So del dot B, okay, I'll call it another vectors. Instead of V, I'll consider vector field. So I can consider one A, it's a vector field, that is a x, x vector, a y, y vector, and a z, z vector. Then del dot A is simply given by del AX, del x, plus del AY, del y, plus del AZ, del z. It will give you how much in this field, no? So if I draw this figure, this is x, this is y, and it is z. So I can consider one cube or any closed surface. Okay, I can consider one cube here. So how much field is incoming to the surface and how much it is going away from this, leaving this surface, other surfaces. Okay, so total incoming minus outgoing. Okay, but it is the diverging, so total outgoing minus total incoming, that will be considered as total outgoing flux, and that outgoing flux we can define it. So this is basically, it is defined by A dot ds. This is the area integral, the closed area integral, and after this small volume del V, and if we take a limit delta V tends to 0, that will give you the divergence at the point P, certain point P, and for this vector field A, and that is denoted by del dot A. So we'll be discussing this part in detailed way. This is very useful. We'll be using divergence method, and here divergence theorem will be there. So that will relate the surface integral to volume integral, divergence theorem. So next one is the curl one. So curl will be simply the curl of A. So that will show you how much rotation is there in the vector field. Okay, so these three, what I want to mean, these three, gradient, divergence, curl, these are most useful to you. You need to understand it. Okay, and next, so to understand this thing, obviously you need to understand these line integrals. So these three line integrals are important. So one is closed line integral A dot dl. It could be closed surface integral A dot ds, and it could be volume integral and A dv, or any scalar field also v dv. Okay, these are the volume integrals. So you need to understand how to compute the line integral, how to compute the surface integral, how to compute the volume integrals. Okay, and what the relation between line integral, surface integral, and volume integrals. So we will be getting these two theorems. One is called divergence theorem, okay, that will relate this A dot ds to the volume integral, and volume integral will be del dot A, the divergence of A dv. This is a closed and this is open. This is a closed surface S, this is a closed, and this is open that containing the volume. Okay. Similarly, we will be having one more thing, Stokes theorem. In Stokes theorem, we'll have the relation between this line integral A dot dl with the surface integral, open surface integral, and that will be the curl of A dot ds. So these things will be discussed again in detailed way, and these are very much useful to understand electrostatic, magnetostatic, everything. Okay, you can't skip this part. And two more important thing is that, so far I am saying that in Cartesian coordinate system, but we need to understand cylindrical as well as spherical coordinate system, because these are also useful to use this electric field and magnetic field, and to understand, to compute certain things. So if we use cylindrical or spherical coordinate system, we'll get certain advantages. So what are these two? So in cylindrical coordinate systems, we are having this any point P. So this point P we can write in three form. One is rho and phi and z. Okay, so these three are important. So the rho is the distance. So this is the rho distance from this z axis, and phi is the angle with x axis, right? And this z is the vertical height. This is the z vertical height. So these three parameters will be there, and for that three unit vectors we need to find out: rho vector, phi vector, and z vector. So here most important thing is that, so what is the elemental length vector? And that will be d rho, rho vector, rho d phi, phi vector, and dz, z vector. And how will get these things, and what is the relation with the x, y, z for this cylindrical coordinate system? Everything we will be discussing. So here idea is that point is located on the surface of a cylinder. That is the idea. Okay. So from that concept, we will define unit vectors and elementary surface, elementary volume, everything. So next, the other one is spherical coordinate system. There the parameters, any point P will be considered as these three parameters. One is r, that is the distance from the origin, this one. Then theta, it's the angle with z axis, and the phi again similar to this one, angle with x axis. So here again we will be getting three unit vector, r, theta, and phi, and we need to understand what is the elementary length, dl vector, and what is the elementary surface vector, and what is the elemental volume, dv. So these three things we need to understand. So it will be simply dr, r vector, but rho d theta, sorry, r d theta, theta vectors, and r sin theta, d phi, phi vector. So those things will be discussed in detail. It is not very hard to understand. If you follow my lectures, you will easily get it. Okay. So these are all about the vector calculus. You need to understand the vector calculus well, then only you'll be able to understand electrostatic, magnetostatic, everything. Okay, so I have already said that electrostatic is in your part. Okay, there you need to understand Coulomb's law and Gauss theorem. This is the most two important thing, and also potential, how to define the potential, and what is the relation between electric field and potential, and then Laplacian operator, those things will be also useful. Poisson equation will be useful. So there are lots of things, but those will be discussed one by one. Okay, then the idea is magnetostatic. So electrostatic, I have said that it is due to the static charge, when charges are under rest condition. And magnetostatic, it is not actually the permanent magnet kind of things we will be using. It's not pole south pole kind of things. But here we will be considering one steady current. If a DC current is there, that is flowing through a conductor, then nearby to this conductor we will have one magnetic field. That we will try to observe it. Okay, so you can understand this thing. Whenever charge is under rest, then we are getting electric field, electrostatic field. So here the DC current, what is the current? Current is nothing but the flow of charge, dq dt. So whenever charge is under motion, and it's a constant motion with equal speed, okay, DC current, in that case you will be getting a constant magnetic field. So this is magnetostatic. So in this magnetostatic, you need to understand these two laws first, the Biot-Savart law, and other one is Ampere's circuital law. What is the Biot-Savart law? This H field or a B. So these are B and H. These are related by B equal to mu naught into H. Okay. So this B field, according to Biot-Savart law, we can write that this mu naught into this current I upon 4 phi, and then you need to take, so this, if this is a ds vector, so this ds vector cross this r vector, okay, or this r unit vector I can consider, and upon this r square. So this is the magnetic field due to this current element IDS. Okay, this is Biot-Savart law. And if you simplify, so the Ampere circuit law, it says that if it is this one current is flowing inside, around this one you will be getting one magnetic field, H or B, whatever you can write. So H field, so this H dot dl, so this, if I can consider, is a dl element. Okay, this closed line integral, it is always equals to the current passing through this wire. So H dot dl equals to simply I. This is your Ampere's circuital law. That will be discussed in detailed way. So these two are important to understand. What is Biot-Savart law and what is Ampere's circuital law. Okay, and then you need to go for electrodynamics, okay, and Maxwell equation. In electrodynamics, you need to understand Faraday's law and Lenz's law. These two are important, and there, if so, how to generate EMF, that I can write minus n times d phi dt. If there is any magnetic flux change, we'll be getting, it can generate the electromotive force, okay, or voltage. That thing will be discussing in detailed way. You need to understand this one. And next one is Maxwell's correction to Ampere's circuital law, because you will find this concept like this way. Suppose if you have one capacitor, and you know that capacitor is nothing but it's a two plates, and inside that one you have one dielectric, okay, insulator. So silicon dioxide could be there inside these two plates, and these are two conducting plates. And now if I connect one resistor and one voltage source, so you can see that the current can flow. Okay, so here this resistance is there, it's fine, it's a conductor kind of things, so current can flow. But inside this one, it's a dielectric. Through dielectric, current cannot flow, right? So so whatever charges are coming, so these are electrons. The electrons are generated by negative polarity. It is coming up to this point, and these electrons can come up to this plus terminal. So plus terminal will attract these electrons. It's fine. So there is a movement of electron here, but how electrons are moving inside the plates? So within this one, it is not a conductor, it's an insulator. So electron cannot move, okay, through this insulator. It cannot go through. So it can come up to this one. So electron can have to go up to this plate. It can store there only, and electron come from here. So how current is flowing inside the plates? So that cannot be explained by this conduction current. So we need to introduce displacement current. Okay, that was introduced by Maxwell's. So those things you need to understand. We will be discussing in detailed way. What is the displacement current density factor? All those things. Okay. Then we'll be having Maxwell equation. So 4 Maxwell equation we'll be getting. Those are very, very useful. So Maxwell introduced one correction term here, and others 3 equations we'll be getting, and total 4 equations we'll be calling it Maxwell equation. So we'll understand those things in detailed way. And then we'll discuss electromagnetic waves, how electromagnetic wave is generated. So when you will get electromagnetic waves, so we can say that electric field is there and magnetic field is there, and both are time varying. Okay, then electromagnetic wave is generated, and we can show you that E cross H, this one is nothing but P pointing vectors. So that is the direction of the electric field waves, all those things, and it will also give you the density. So those things, pointing theorem, you need to understand in electromagnetic waves, and how to define the electromagnetic waves, everything. So there, the most important thing is wave equation. What is the wave equation? How it will propagate in the media? What kind of equation we can consider? In that it should be time varying, it should be at space varying. So it's a function of space as well as it's a function of time. That is the important concept in wave equation. We need to understand that one. And the solution of the wave equation. And then we'll be considering plane waves, the wave polarization, wave propagation to the media, everything. And there we'll see that the refractions, everything. If the wave will hit in a dielectric, what will happen? So suppose the wave is, this is your one media, mu1 epsilon 1, this is your mu2 epsilon 2. So one wave is coming here, and then it can get reflected back this side, and some part it is transmitted here. Okay, so what is the reflection, what is the refractions, transmissions, everything will be discussed in detailed way. And their polarization is the important thing, how electric field is polarized. So what is the meaning of polarization? Those things will be also discussed in detailed way. Okay, and then the idea is that radiation and antennas. This EM wave is useful to understand the radiation. Okay, and so in communication channel, we use antennas to radiate certain things. I have one message signal, like suppose I have one microphone. So here we are speaking in front of microphone. Here we will get one electrical signal VT, okay, or MT, suppose I write MT. So this message signal, we can amplify it if the amplitude is low, and then we'll use one modulator to modulate these things. Modulator means we'll convert this low frequency signal to high frequency signals, and then we'll use one antenna, transmitting antenna, to transmit the EM wave to the space so that it can cover a larger distance. Similarly, to a receiving end, we'll be using one receiving antenna, and then we'll be using one demodulator, and then we can use one speaker kind of things, okay, to get sound wave. So this is a very simple mechanism in communication systems. So there are lots of things, it is very simplified form. So I'm saying that this antenna part is important here. How antenna will radiate EM wave, okay, EM wave. So that will be discussed in detailed way. You need to understand this one. Once you will get electrostatic, magnetostatic, and electrodynamics and electromagnetic waves, now we can understand this radiation by the antenna, transmitting antenna. Okay, so we'll be discussing this kind of dipole antenna. This is one simple conductor bar that could be used as a dipole antenna. So here in this, through this wire, so if we apply certain current I, so this current should be AC current. If it is AC current, then this conductor will radiate EM wave in this side. Okay, this is a simple dipole antenna. So what is the meaning of dipole, that I'll discuss later on. So two pole kind of things. And then so I can have, this is one radiator, I'll call it radiator, main radiator. So I can have folded dipole in Yagi-Uda antenna. This is called folded dipole. I can have one reflector part, and I can have other director parts to get certain directions. So you can see there I have shown the patterns. So in dipole, so this side you will be getting more radiations, and this side almost zero radiations. So you can see that radiation magnitude will vary along this angle. So this side it will radiate more, and this side it will radiate zero, no radiations. So okay, the pattern is like this, and this side pattern is like this again. Okay, but suppose this is one transmitting antenna, I have one receiving antenna this side, I need to transmit only this side only. So this lobe is not useful for me. So can I reduce this lobe? Because this side also it will transmit, this side transmit, but I have one receiving antenna this side only. So this part, how much it is radiating on the back side, it is useless for us. So we want to minimize this kind of radiation, back lobe radiation. So that could be used in Yagi-Uda antenna. So in Yagi-Uda antenna, we can have one side radiation pattern this side, and this side very small. We can reduce it. So because of these reflectors and directors along with the main radiator. So here the current, this signal is coming. Through this wire, the signal is coming, okay, and because of that it will radiate. But these elements will help us to get this kind of beam width, okay. So here we will consider beam width. So this angle, so this angle is called beam width, fine. So this kind of directed radiation we can have. So to get this one, we can use the antenna arrays. So several kind of antennas. So more than one antenna we can use. So here two antennas we have shown that, and we can have this kind of antenna arrays, and radiation pattern, different kind of radiation pattern we can get it. Okay, so I can use 2 antenna, 4 antennas, 8 antennas. So several pattern will be getting, and how to get those patterns. So those things we need to understand it. So one important thing is, first we need to study dipole antenna first, and then we should go for antenna arrays. 2 kind of antenna arrays we will be discussing. One is end fire, and other one is broadside antenna array. Okay, fine. The next one is the transmission line. That is also very useful. So in transmission line, so what is this? So you have seen that there are long wire lines from stations. This is electrical signals is coming into long lines. So you can see that these lines are coming over kilometers. So if the electrical signals is going through a long line, then here if you apply one source, right, and here if you use one load kind of things, ZL, you may not expect every point the same voltage or same current will be there, because this line is very large, length is very large, and if it is especially very large compared to the lambda, where lambda is the wavelength of this signal, this is power supply. If it is so, then in several places you will be having several voltages. So it is distributed kind of things. You can't expect through the line the same voltage you will be getting everywhere. No. So it's a distributed kind of things. So there, what are the characteristic equations? How much this voltage will be reflected back, everything. There are lots of concepts in this way. So characteristic impedance, BSWR, voltage standing wave ratio, reflection coefficient, everything will be discussed in this field. Okay, so transition line is the most important thing, and that thing you have seen that in your TV set as well. Suppose if you have one TV set, and suppose I have one antenna, receiving antenna here. So from here to connect to TV set, we'll use one wire, and you can see that this signal is having very high frequency. F is very large. So if F is very large, lambda is small. So if lambda is small, this length, suppose if it is few meters, so 10 meters, then also it is sufficiently larger than lambda. So lambda could be less than a meter. Okay, so in that case, this line, these parallel lines could be considered as transmission line, not a simple line. Okay, so we need to understand what is the characteristic impedance of this one, so that it is perfectly matched. So this characteristic impedance should match with the impedance of this TV set. That should be maintained. Then only you will be getting maximum power transfer, everything. Okay. So there's lots of things will be there in transmission line. We'll be discussing all the things one by one. Keep watching. And now I'll discuss which book you should follow for this course. Okay, there are lots of books, useful books. But I'll suggest few books. Those will be useful to you. It's very easy to go through. Okay, and also content wise it is good. So first one I can suggest that the Griffith, the Introduction to Electrodynamics, Griffith book. This is very easy book. It's fundamental books. Okay, you can understand electrostatic, magnetostatic well, and you can get up to this radiation part. But this one, electrostatic, magnetostatic, plane waves, everything is covered in this book well, and radiation a little bit, dipole only it is covered there. But antennas is not covered in this book, so you won't get the antennas in that way. So if you want to understand more about antennas, radiation, transition line, everything, so you need to go to other book. Okay, so this is only for the first part, EM theory part. Okay, and next book I can suggest you the Jordan and Ballman, and this is electromagnetic waves and radiating system. Here radiation part is discussed in detailed way. So in engineering point of view it is discussed there. So I'll suggest this book for this antenna, transition line, all those things. There's one book, more book also there for antenna, Krauss, that also you can go for. Another book I can suggest, that is Elements of Electromagnetics by Sadiq. This is also very nice book. Here also you will be getting all the things. Okay, you will be getting transition line as well in this book, right? And one more book I can suggest, that is called Height and Bach. Okay, so any book you can follow. So these are all good books. But in my course, I'll discuss these points very briefly, and so that all of you can understand these things easily. Okay, so I may not follow a one-stage book. So from my experience, I'll be discussing this content. Hopefully it will be useful to you. And if you want to get more content, and you can subscribe these channels to get the future videos. And if you see that this kind of videos will be useful to you, then you can press the like button. So I'll discuss more about this EM theory. This is just only starting point. And in the comment section, you can write this one. So which topic you need most. So if you have some kind of suggestions, you can write it down there, so I can make those videos fast. Okay. Suppose if you want transmission line first, you can ask me. So transmission line without EM theory also we can discuss a little bit. Okay. And antennas also we can discuss certain things. So if you need those kind of concept early, then you can request me in the comment sections. I can discuss. I can consider that one. Okay. So thanks for watching. We'll be discussing more in my future videos. Thank you.